NASA held a highly anticipated press conference on November 19, 2025, gathering journalists, scientists, and space enthusiasts from around the world to reveal a collection of new images taken by various spacecraft and telescopes of the interstellar visitor known as Comet 3 I/Atlas. Interest in this object had grown rapidly in the weeks leading up to the event, especially as rumors and misleading claims spread across social media, suggesting that the unusual trajectory and composition of the comet might indicate extraterrestrial origins or alien technology. To address these speculations directly, Associate Administrator Amit Kshatriya opened the conference with a reassuring and grounded statement. He emphasized that Comet 3 I/Atlas is, without question, a natural interstellar comet, the third such visitor ever detected passing through our solar system, and that there is absolutely no evidence linking the object to any form of alien life or artificial construction. His calm, factual explanation helped reframe the discussion, focusing attention back on the remarkable scientific opportunity the comet presents. Kshatriya then introduced a series of images and data collected by NASA's fleet of spacecraft, each of which had been carefully repositioned or instructed to observe the newly arrived object. Among these spacecraft, the Mars Reconnaissance Orbiter achieved the closest and clearest view. On October 2, 2025, while orbiting Mars, the orbiter captured an astonishing image of Comet 3 I/Atlas from a distance of about 19 million miles. Considering the vastness of space and the challenges of photographing a fast-moving, dimly lit comet, the image stands as a testament to both the orbiter's precision instruments and the planning of NASA's observational teams. Scientists describe the image as not only visually striking, but also scientifically valuable, offering clues about the comet's surface features, dust emissions, and the structure of its developing coma. While NASA's official images attracted global attention, amateur and independent astrophotographers contributed their own remarkable observations. Three highly skilled astrophotographers, Michael Yeager, Gerald Riemann, and Enrico Prosperi, shared some of the earliest high-resolution views of 3 I/Atlas as it emerged from its closest approach to the Sun. These individuals, well known in the astrophotography community for their consistent documentation of comets, asteroids, and deep sky objects, used their advanced equipment to capture the comet's transformation shortly after perihelion. On October 29, 2025, the comet passed its closest point to the Sun, and the heat and radiation dramatically altered its appearance. The trio's images, posted to the ICQ Comet Observations page on Facebook, revealed details that even many professional observatories had not yet captured. Their work showcased the comet's evolving tail, increasing brightness, and the subtle structure of material streaming away from its nucleus. Viewers on social media and within the scientific community expressed admiration for these images, which demonstrated just how dynamic a comet can become when influenced by the Sun's intense energy. The visual evidence showed that 3 I/Atlas had undergone significant physical changes during its solar encounter, much like other long-period comets from our own solar system. The intense heating caused ancient ices within the nucleus to vaporize, triggering jets of gas and dust that burst outward in multiple directions. These jets, now clearly visible, created dramatic plumes radiating around the comet, giving it a more complex and active appearance than earlier in its journey. The amateur images also provided researchers with additional angles and lighting conditions not always available through NASA spacecraft, making them valuable data points for modeling the comet's composition and behavior. The uniqueness of 3 I/Atlas lies not only in its appearance, but in its origin. It is only the third confirmed interstellar object to be detected passing through our solar system, following the discoveries of 1 I/Oumuamua in 2017 and 2 I/Borisov in 2019. Like its predecessors, 3 I/Atlas is believed to have been formed in a distant star system before being ejected into interstellar space, eventually drifting close enough to our solar system to be detected. What makes each of these objects especially intriguing is that they offer scientists a rare chance to study material that formed around another star, material that may be billions of years old and unlike anything formed within our own planetary neighborhood. Every observation adds to humanity's understanding of how planetary systems form, evolve, and interact with their environments. During a press conference, NASA confirmed that the comet reached its perihelion, or closest point to the Sun, at precisely 11:47 Universal Time, coordinated on October 29, 2025. At that moment, it was approximately 1.36 astronomical units from the Sun, roughly 126 million miles, or 203 million kilometers. Though this is farther than Earth's orbit, the comet still experienced significant heating, enough to release large volumes of gas. Scientists monitoring the event noted that the jet activity observed after perihelion was stronger than initial models had predicted. The comet, surprisingly active for an object of interstellar origin, appeared to react dramatically to solar energy, suggesting that its surface contained volatile compounds that had remained frozen and untouched since its formation. Following its passage by the Sun, Comet 3I/Atlas began traveling outward again, continuing on a hyperbolic trajectory that will eventually carry it out of our solar system forever. Before it departs, however, the comet still has one more notable moment ahead, its closest approach to Earth, expected around December 19, 2025. At that time, it will pass approximately 1.8 astronomical units from our planet, which is not close enough to pose any danger and also not close enough for the comet to be visible without telescopic assistance. Even at its brightest stage, scientists confirm that 3I/Atlas will never reach naked eye visibility. Its faintness is due not only to its distance, but to its relatively small size and the dispersal of its light over a broad, diffuse coma. Despite this, the event has generated excitement among astronomers and hobbyists who enjoy observing transient cosmic phenomena. Telescope users, particularly those in the northern hemisphere, will have the chance to search for the comet in the eastern pre-dawn sky. With the right equipment, moderate to large amateur telescopes and dark, clear skies, observers may detect the faint glow of the comet's coma, and, if conditions are especially favorable, some of its jets or tail structure. Astronomy clubs and observatories are already discussing hosting viewing sessions or virtual events where live telescope feeds could allow more people to witness the comet before it disappears into the depths of space. NASA's press conference and the subsequent release of images have renewed global interest in interstellar objects and their scientific importance. Each visitor from beyond the solar system provides clues about how planetary systems differ from one another and what kinds of conditions might exist around distant stars. Because these objects are not gravitationally bound to the Sun, their presence is fleeting. Once they pass through, they accelerate outward and are unlikely to ever return. This reality creates a sense of urgency within the scientific community, prompting rapid international collaboration, data sharing, and coordinated observation campaigns to gather as much information as possible before the comet becomes too distant to study. Comet 3I/Atlas, like 1I/Oumuamua and 2I/Borisov before it, is a reminder of how interconnected the universe truly is. Fragments of ice, dust, and rock that formed around distant suns travel unimaginable distances over millions of years, eventually crossing paths with our own solar system. These cosmic visitors carry chemical signatures and physical properties shaped by environments humans have never seen. With each interstellar object discovered, scientists refine their models of how planets and comets are created, how star systems eject debris, and how this material evolves over time. The study of interstellar comets may even offer clues about the distribution of organic molecules throughout the galaxy, contributing to broader questions about the origins of life. Ultimately, the excitement surrounding Comet 3I/Atlas is driven by a blend of scientific discovery, public curiosity, and the sheer wonder of witnessing something so rare. While it will not shine brightly enough to dazzle casual skywatchers, its presence has already inspired countless conversations about our place in the universe and the surprising ways in which distant star systems can reach across space to touch our own. As the comet continues its outward journey, scientists will keep analyzing the images and data gathered over the past months, hoping to uncover new insights locked within its icy core. For now, the world watches with fascination as this interstellar traveler sweeps past our sun and prepares to depart once more into the quiet vastness from which it came.